Okay, so we need to find the resultant of all these forces, right? The three forces here acting on this particular point here, okay? It's a particle or something. And there are forces pulling in different directions here. And we want to see what is the overall effect of those three forces. Okay, what's the overall magnitude of those three forces? Okay, now we need to focus on each of the forces individually, all right, and in order to sort of resolve them, right, in an x and y direction. So I'm going to call this my x-axis, and I call this my y-axis, all right. Reason for that is that once we've got the overall component resolved in the x direction and y direction, right, we can find then the overall resultant effect, okay? Now, if we just focus on that 7 Newton force to start with, just appreciate it's pulling in that direction, so you go in that direction, all right? And to go in that direction, it's kind of like going across the x-axis and up the y-axis, isn't it? It's a bit like coordinates, isn't it? You've got to go across and then up to get to that particular point. So if we are going across the x-axis and up the y-axis, it's going to go across the x a certain amount and up the y a certain amount. So we're going to have an x component and a y component. So to work out, literally how much we go across, right, and how much we go up, we need to form a triangle, right? You might see that sort of triangle already starting to form there, but for us to make it slightly clearer, I will draw the triangle by the side of it, all right? So just appreciate then that you've got the 7 newtons, okay, at that angle there of 30 degrees, okay, all right. And just appreciate to get sort of going in that direction, you've got to go across a certain amount and up a certain amount. Now, if we look at the sort of triangle we've got here, it's a right angle triangle, and we know that side there is the hypotenuse, okay, and we know this side here then is the opposite, because it's opposite the angle of 30 degrees, and then we've got the adjacent here then next to the angles, okay. Now, I know this side is 7, and the good thing is that I can work out what the adjacent is just by using SOHCAHTOA, yeah, okay. So I can work out what that component is, how much we go across, by working out what A is. And because I already know H, A and H will be cos, so be cos 30, okay, equals to A over H, so be A, divide by H, which is 7, and all you've got to do then is take that 7 up to the side, and you get your A, don't you? You get your A to equal 7 cos 30. So because that side's A, I know that component now is 7 cos 30. Okay, and I can do a similar thing then for the opposite. Okay, the opposite then will end up being 7 sine 30. Alright, do a similar thing because you've got opposite you want, and you've got the hypotenuse given, so you can use the sine. Alright, so now the component of 7 Newton along the x-axis is 7 cos 30, and along the y-axis is 7 sine 30. So when I resolve that force then here, okay, along the x and y-axis, right, we do a cross, right, and we literally then put in 7 cos 30 here, okay, because it's 7 cos 30 along the x-axis, 7 sine 30 then along the y-axis. Now we could do similar situation then with the 5 Newton, because the angle is here, okay, the adjacent be this side, so be cos here, 5 cos 50 there, and 5 sine 50 there. And then with the 2 newtons, was pull in this direction, so it'll be 2 cos 60 along the x-axis and 2 sine 60 along the y-axis. Okay, so I've got all my forces there now labelled. So when I resolve then, I look at what the resultant force is in the x direction, okay, going this way. So I've got 7 cos 30 going that way, but I've got then these 2 forces then sort of going the other way, opposing it, so I'm going to take them away. Right, so I literally then type that into my calculator, make sure I'm in degree mode. So we've got that, take away 2 cos 60, and I get out to be 1.84824. Now it's important to have some decimal places there, so I've gone to 5 decimal places, so we have accuracy in our answer. Now when we resolve in the in the y direction rather than, right, in the y direction, we've got then the 5 sine 50, plus then the 7 sine 30 going that way, and then opposing it is the 2 sine 60. Okay, so I'll type that into my calculator. And I get out my answer to be 5.59817, right, to 5 decimal places. You can see now they're both positive, right? So what that means is the overall effect of those three forces, right, means that we've got 1.84824 going to the right, okay, along the x-axis. And we've got then 5.59817 going in the y direction, okay, this way, 5.59 in the positive y direction, 817. Now, that means then, if we go in 1.84 blah, blah, blah across, and then 5.59 in the positive y direction, the overall effect is going to be something like this, okay? Right, that's going to be the overall resultant, right? Now, what I can do then is I can put these forces together to stay balanced, right? In other words, that resultant here is equivalent to that 1.84 blah, blah, blah going across, okay? And, of course, then that 5.59817 going up. Okay, going in the positive y. Alright, so it's equivalent force diagram, right? The R is the same as 1.84 going that way, 5.59 going that way, okay? They all sort of match up there, okay? That's what the resultant is, the equivalent of the resultant is going across here and then in the positive y direction that way. Now, we can work out R, can't we? Because clearly you can see here, it's a right angle triangle. And we've got Pythagoras. Okay, so I just got to square that and square the other one. And then, of course, square root the answer, because that's what you do with Pythagoras, isn't it? Square both sides, add them, and then you take this, because the other side's square as well, but you take the square over and square root. So if I work that out, I get on my calculator R to be 5.895 newtons to 3 decimal places.